Hello class, this is Mr. Lehman. I want to talk to you today about smells, lesson 15. It's all about attractions between molecules. And in this lesson, in section 3 of the smells unit, we deal with two new words, polar versus nonpolar. Polar molecules versus nonpolar molecules. And we did a lab. We did a lab for this lesson. And the first part of the lab, we did a charged rod test. And in the charged rod test, you took the rabbit fur and the rod and you rubbed them together. And what happened? Some electrons were transferred from the rabbit fur onto the rod, making it charged. Electrons have a negative charge, and so our rod has a negative charge because there's a bunch of electrons from the fur on the rod. And so what we did is we passed a very thin stream of liquid near the charged rod without touching it. And if that liquid curved towards the rod, that means that it was attracted to it. And so we saw that 3 of our liquids did curve towards the rod. 1, hexane, did not. If it did not curve, that means it's not attracted. And so if we get into what is a polar molecule, what is a nonpolar molecule, we have some definitions here. So for something to be polar, a polar molecule has oppositely charged ends. Polar molecules have oppositely charged ends. So I will draw a water molecule here. We have oxygen and we have 2 hydrogens. And so they don't share the electrons equally. And we'll learn later in lesson 17 exactly how to figure this out. But the oxygen's the bully here. It's pulling the electrons closer to itself. Electrons have a negative charge, and so oxygen itself becomes partially negatively charged. This is a delta symbol, meaning partially negative. And then because hydrogen's having its electron pulled away from it, if it's losing part of that negative charge, it becomes partially positive charge. And so we can look here at a water molecule. We can draw a line, and we can see the top half has a negative charge, partial negative charge, and the bottom half of our water has a partial positive. So now if we take a look at what's actually happening here, as our water molecules pass down by that charged rod, what we see the bending coming from is that the positive end, the hydrogen end of the water, is being attracted to that negatively charged rod, causing it to bend. So that brings us to a second example. Well, if it didn't bend, what's happening? And so we have nonpolar molecules. Hexane, which did not bend, is a nonpolar molecule. Nonpolar molecules do not have oppositely charged ends. They do not have those opposite charges on the ends. Nonpolar molecules do not have oppositely charged ends. So let me show you something here. Let me show you hexane. Hexane has 6 carbons and it has 14 hydrogens. 6 carbons, 14 hydrogens, arranged in a relatively straight chain here. I know it's a little tedious here, but let me draw these in just so you can see. Carbon and hydrogen share electrons relatively equally. And so if they're sharing electrons relatively equally, then there are no charges. If everything's sharing roughly equally, they're not gaining any electrons, they're not losing any electrons. They stay neutral. And so if this is all neutral, if that neutral substance, which does not have any charges, passes by this charged rod, it has a negative charge, there's no positive charges on that hexane to be attracted to it. So nonpolar molecules are not attracted to the rod. And so it comes down to intermolecular forces here. So what kind of molecules have stronger intermolecular forces? What kind of molecules are strongly attracted to one another? And so going back here, do you think 2 waters will be more strongly attracted to each other? Or do you think 2 hexanes, 2 nonpolar molecules will be more strongly attracted to each other? 2 waters, they have opposite charges on opposite ends? Or 2 neutral, no charged hexanes? Yeah, you're right. I'm hoping you chose this one here. If 2 water molecules come together, the negative end of one water molecule is going to be attracted to the positive end, the hydrogen end. And so here, if a water molecule comes in, it's going to align itself, so its negative, partial negative end is going to be attracted to the partial positive end and line up together. And so I put a dotted line here. This dotted line represents the strong intermolecular forces, or forces of attraction between molecules. So polar molecules have strong intermolecular forces because they have the opposite charges that attract, like little opposite charged magnets. If I had another hexane here, there are no oppositely charged ends to attract each other. And so lesson 15 really does a nice job of introducing the differences in behaviors among molecules because of these fundamental differences between polar molecules and nonpolar molecules. So I hope this helps. We'll get into more detail in the next couple lessons here. Thanks.